Awesome. All right, so we're recording this. We'll be sharing this with you. You'll have the link tomorrow. So we'll try to get that out as soon as possible. So welcome, everybody. I know we have people from all over the world, especially with these online events that we've been doing this year. So good afternoon, good evening, good morning. Welcome. Really happy to see some of you again as well. I'm one of the co-organizers. I'm Joshua Hurst, and we have Vasu on the panel here. We have Chakri. Chakri is a senior architect. He's been working with CNCF open source projects for a long time. He's been around for a while, and he's going to be helping to host and moderate today's discussion. And we have Samia, who I'll introduce more formally in just a minute. But for those of you who don't know, we have a lot of people that come to these events through, not only through our meetup community, but come through Eventbrite. So our community is cloud native at scale. We're based in San Francisco, and we focus pretty much exclusively on CNCF cloud native projects. And we talk about containers, microservices, observability, GitOps, and everything in between. So all of the usual suspects. Today's event, the title for today's event is Where's My Container? Visualizing the GitOps Container Journey. And so just to set the context a little bit, as most of you know, GitOps has become the de facto approach to enabling simple, secure, and audible deployments. However, when you deploy to multiple Kubernetes clusters, knowing where your services are in the GitOps journey can be challenging. In addition, it can also be almost impossible to track permutations of service versions across clusters with current tools available. So today, what we will be discussing is the need for observability in GitOps pipeline that grows due to microservice architecture, growing teams, et cetera. We'll also be talking about Kubernetes workloads, best practices in a GitOps architecture. You'll see a comprehensive dashboard view of a container's journey from code, check-in to deployment on Kubernetes clusters, and you'll learn concrete patterns for testing in production with GitOps and deployment rings. So Samia, I hope I got that. And so let me introduce Samia Akhtar. She is a software engineer at Microsoft. She's on the commercial software engineering team. They're building tools for Azure customers in the GitOps and cloud native space. And she's super passionate about open source projects, GitOps, and front-end related projects that enable teams to increase productivity. So without further ado, Amia, I want to really thank you for joining us. We're looking forward to your presentation, and I'll go ahead and turn it over to you.
Thank you so much, Josh, for the amazing introduction. Hopefully you can all hear me well. So I'm really excited to be here. And again, thanks to Josh and the organizers for inviting me to this event today. So yeah, let me start sharing and we can dive right in. All right.
And maybe I should say real quick, if you have questions, feel free to ask questions throughout and go ahead and put it in the Q&A box, not the chat box, but the Q&A box. It'll be easier to manage it that way.
Yes, that's a great point. Yes, please feel free to ask any questions. So yeah, before I jump into all the fun GitOps observability stuff, let's do a quick recap for some of you and for those of you who would love to learn about GitOps. So what is GitOps? It's the idea that a version control system like Git can store all code, documentation, configuration for a Kubernetes application. And it includes the use of automated operators to sync changes to your cluster, such as Flux. Git remains the single source of truth. And Kubernetes being declarative, it tries to match the state in the Git repository at all times. So as developers, we are all familiar with Git, and we're able to use this knowledge to push code into the cluster. So that's basically the idea behind GitOps. So a very simple GitOps process looks like this. You have developers pushing code into their Git repositories, which kicks off a CI build, and that pushes a new Docker image for your code change. And your cluster is running an operator such as Flux, which is also synced to a config repository. and it can pull the Docker image and apply the Kubernetes manifests from the config repository. So that's the idea here. And what is exactly, the observability here around GitOps? In simple words, I like to think of this as observing what really goes on in a GitOps process by combining GitOps and the monitoring tools all together. So in any typical workflow, you have a release, you're observing the release, your orientation around what you just released, and then you go and make a decision based on your observation. So in the case of GitOps observability, we are mainly concerned with the left side of this, which is all about your acting and releasing, because there are already multiple tools out there that people use for in-cluster monitoring. Being able to know how long something takes to get into your cluster, if a pull request is blocking deployment, and if a deployment did go through, did it go through successfully? Or did it introduce a breaking change? Or even just to identify if a pending pull request to master even works. So all of that is really important. And that's what we want to tie back to the Git commit it came from and all of the metadata that surrounds it. So that's the area that we'll be focusing on. So as part of this organization in Microsoft, we've been focusing on working with several customers. And what we've seen is problems start to increase with more microservices and organizational complexity. So the reality is that teams work in branches. Oftentimes, applications will be deployed from branches other than the main branch. And if you're embracing a microservice architecture, you most likely have services across many branches. Coordination between developers and operations teams also increases complexity. So if you're multi-tenant or if you're performing ring deployments, we will get to deployment rings in a bit. For example, teams may be performing ring deployments or flighting features, and that adds further complexity to how we release the software. Another one is inconsistent feedback cycles. So let's say you're working with several teams and a couple of them need to do some rollbacks. How does it look in the overall GitOps view? How do we know what's going on? So these are some of the challenges that we have seen with our partners. So let's consider a scenario where GitOps can be applied to understand this further. Fabricam Trivia is a small team building a trivia website. So as you can see here, they have a simple UI and they're trying to increase their usage by expanding this to include several different APIs into their website. And those could be built by different teams. So let's dive in and see what their scenario looks like and if GitOps can help them. So until now, they had a small monolith application, and now they would like to modernize their setup to include deployment of microservices. Perhaps each of the different trivia topic could be served by a different API module. And the main idea behind a microservice architecture is that applications are simpler to build and maintain when broken down into smaller pieces that can work seamlessly together. So here you can see they have a front-end microservice and a back-end, and they could have several different API modules coming from different microservices, and they could potentially add more microservices in future. So the trivia engineers learn about GitOps and they begin to apply that into their system. So they start to store Helm charts for their environments in a specific folder in their repositories. And then they start using multiple CI/CD pipelines for their microservices. And as you can see here, you could have a lot of developer teams pushing code into their repositories, lots of CI pipelines, lots of CI builds, generating several Docker images. And then the approvers could be a few other individuals from those same teams approving those changes and deploying a lot of things into the cluster. So this architecture finally allows Fabricam Trivia engineers to incorporate work from several teams. But now their developer, Danny and Oliver, run into some new problems. They're finding that multiple microservices pushing into the same cluster can also become complex. So they could be, for example, they're finding that there's too many CI/CD pipelines and tracking is difficult. So each microservice has a pipeline for the CI build and another for their CD build, already resulting in 2 end pipelines in their system. They also have difficulty versioning. So developers have trouble testing their own beta versions with stable versions of other microservices. So they want to decouple microservices from each other. And their operator is lacking observability into what gets deployed, versions, audit logs, and sometimes he has trouble fixing issues if bugs make it into production. The trivia engineers also realize they would like to test their features in a single cluster to cut cost because they're a small company. They learn about the concept of deployment rings. So deployment rings basically is a concept that allows multiple environments to exist in a single cluster with the help of a service mesh. And deployment rings will allow you to also group users into cohorts based on features of your application you wish to expose to them. It's similar to A/B or canary testing, but in a more formalized manner, in which you roll out changes from a smaller ring to a larger ring. So this would allow them to test their features in, let's say, the production cluster by setting a header on the ingress routes. And this way, each individual developer is able to test their features in that cluster, but without disturbing the main default production ring. So here's how a developer working on a new feature can first test their features in a ring within the same cluster, and then advance it to the header that's being used by early adopters, and finally make its way into production when it has been well tested. So this concept of deployment rings has been widely requested in our interactions with customers that are using GitOps with Azure. So Oliver is on call, and one night he gets a call at 3 a.m. We all love that, right? He finds out that there is a bug in production and that needs to be addressed immediately, but he needs help from the right developer to fix this bug. He wants to be able to glance at a page and find out the right contact whose feature recently made it into production. And he would also like to know how long this would take for a deployment to go through approximately, so he can update the customer on the line. So we're talking about all of these different things we want, but what's the ideal solution? What do we want? So we are finding that our customers are using different CI/CD orchestrator tools. Some are using GitHub Actions, some are using GitLab, some are using Bitbucket, Azure repos. So the idea is that the ideal GitOps observability tools should be portable. Even within a company, you can have several teams using different CI/CD tools in some cases. So we want to support different storage solutions, container registries. A tool that can be plugged into a new ecosystem easily is desired. Secondly, we want the solution to be lightweight, fast, and easily pluggable anywhere by just launching a Docker image. So this ties back with our observation that some customers may want to embed this software internally or host it behind an authentication layer. A lightweight solution allows easy plug and play. Third, we want this to be secure and not require access to the cluster, and work behind any custom security configuration that they have set up by the organizations. So there are already many tools out there that offer cluster monitoring, so we don't need to reinvent the wheel here. Fourth, we want the solution to scale easily as microservices grow. One of our recent customers had a really large number of microservices that calls for a very good user-friendly filtering experience, along with the need to handle large deployment data in the storage. Fifth, we want to support different deployment strategies, such as deployment rings and environments. As we were working with a customer who wanted to test features in a dev cluster, we found that developers increased productivity by being able to create a new ring easily by creating a branch with a specific naming convention, and then being able to test their feature and tear down that branch after. And it would be ideal if we could monitor these rings in the tool as well. And lastly, we want this tool to help us predict the time and success rate of the deployments by glancing at a page. This is very helpful when we can see durations for the last few recent deployments. So now we will look at one way we solved this with our recent project, Spectate.
Yeah, sorry for interruption. Okay. Can you also touch base or share your views on what is the kind of impact on the developers when we introduce this observability? Is there any additional overhead on developers, or is it going to be mostly additional overhead on the operation side? Like, who is going to be the main stakeholder for this one?
Great question. I think some overhead will be from obviously setting this up. But I like to think of it as, if most teams don't have this idea of having an operator team and developer team separately. But if they do, then this could be something that's handled by the operator team. But I think I like to think of this as a lot of initial setup, but I think the reward is really great, right? Once the team is really, busy and trying to deliver a deadline, for example, this kind of a tool can really help speed up, finding issues and correcting them. But yes, obviously there is, the time to the initial setup time, which is an investment always. So I think it's a trade-off. Definitely, it's a trade-off.
So is there a change in how the manifests are created, or is it going to be same as like developers are going to create Helm charts and then the rest of it is taken care by the observability platform like this? So what I'm trying to understand is there a change in how we build manifest?
There will be a change, and I will be talking about that in a bit. So the Helm charts would be exactly like how the developers are used to creating, but once they make their Helm charts, they can automate a few variables inside of it, which will be coming through from the pipelines. So okay. I will be showing an example of that in a bit.
Thanks.
Yeah, thank you for the question. So let's dive into Spectate, and we will be seeing a demo shortly. So Spectate is our GitOps observability tool that provides a dashboard with a tabular view into the recent deployments. And this kind of helps answering a lot of questions, such as what microservices are running from CI all the way to the cluster, what deployment rings are they tied with, who are the authors of these deployments, is there a deployment waiting to be deployed into the cluster, and if it has already been deployed, who approved it, what changes were made in the Helm charts and the cluster config. And at the end, we will see how is this even, how are we making sure this was synced successfully by Flux. So as we talked earlier, this gives you an insight into the journey your container takes before it gets into the cluster. Next. So we will see a quick demo at this time. I am going to pull up the live dashboard so we can kick off the demo here. So hopefully you can see my browser. And this is the simple trivia website that we've been talking about. It's a simple demo website, so you can see it just has a bunch of simple questions. And for the purpose of this demo, I'm going to try changing the title here to something else, and we will see that change go all the way from code check-in into the cluster. So let me go and modify the file here. It's a very simple JS file. I'm going to change this to, let's say, hello cloud native. I'm going to commit this to the dev branch because I'm going to modify the dev branch. So that change has been kicked off, and this is a demo of Spectate. So in a few moments, we will be able to see the change that we just made show up here. But as you can see, there's a lot of information here. It's a tabular view of deployments. Each of these rows corresponds with one single deployment. And you can see we have the states here, which describe what's the current state. We have the names of the microservices, the deployment rings, who the author is. And then we have 3 columns here that we will see get filled up. These are the CI/CD pipelines for the 3 different steps in this process. So the first step will be the image creation, which is the simple Docker image creation step. And I'm going to come back to this in a few moments when, since our pipeline was just kicked off, and hopefully I can see it running now. Yep, so the one that we just kicked off is running here. And I should be able to see that in a few moments. I'm going to come back to this and navigate back to the PowerPoint because it takes some time to build. So we go back here. So our friend Danny from the trivia team loads up the dashboard and glances at the activity in the cluster. So the image below is a screenshot from Spectate, very similar to the one I just showed you. And when someone on the team merges a new change, you see a row show up on the very top. And you see some columns empty because the deployment is still in progress. So we will see that in a bit. But as the deployment progresses, more and more columns get filled out. Once the Docker image is done creating, we can see that the image creation has turned green. So let me navigate here and see if I can see we can see the change that we just made show up in the image creation column. And this one takes a bit of time because of, the Docker image taking some time to build. So I'm going to navigate back into our PowerPoint, and we can keep going until we come back and find ours done. So these are the changes that we will be seeing soon. So the metadata update column is the one that basically this is the change we're making into the cluster configuration. And that's what gets deployed into, gets changed in the Helm chart and makes its way into the cluster. But this change is actually made through a pull request into the dev branch in this case. So at this stage, someone looking at the page can help unblock a pending pull request to allow developers to test their changes in the cluster. And I also like to think of this, this approval pull request as a stage, it's like a gating stage, which it's like a gate where someone would go and check to make sure the changes that are being deployed are the only ones getting merged. So you can stop, some unnecessary changes from being deployed into the cluster, for example.
So
and if
it,
we merge,
is it going to be in a separate environment? Yes.
So this will be merged into the ring that this is being requested to be merged in. So in this example, the dev ring is what we are trying to merge into. So this, and if we approve that change, that will be merged into the dev ring on the cluster.
Okay.
Yeah, so once the PR is merged, it updates the merge by column with the name of the approver. And then this merge kicks off the final step in the deployment process, which uses tools such as Helm, Fabricate, or Customize to generate the Kubernetes manifests and push them into the manifest repository. So the manifest repository is the final repository it gets to, and that's what Flux is listening to, and we will get to that in a few moments. And Flux is watching this manifest repository, and we should be able to see some update here in the synced cluster column once it's picked up. So in this example, Spectate is currently still using Flux v1, which uses the tag name to determine the name of the cluster. And our assumption is you could have multiple clusters syncing against this manifest repository. I also want to add that the experience you're seeing here is agnostic of the CI/CD tools. So for example, Spectate will build a similar user experience for GitHub Actions, GitLab, Azure repos. And we want to continue adding support for more tools as we work with more partners. So once a deployment completes, we can go to the cluster and run kubectl get pods. We can see that the pods are running. We will get to that in a second. So let me navigate back and see here if ours is not done yet. So I'm going to come back to this in a few moments. So let's dive into Bedrock and the entire pipeline that we have created from code check-in into the cluster manifest is actually coming from Bedrock. So basically, Bedrock is a CLI tool that we have created. It also helps power Spectate dashboard, and it also helps create GitOps pipelines easily and hooks them up for observability. So this way, when you launch Spectate, it already has all the information it needs to show the runs and start visualizing all of this information. In Bedrock, we've also built infrastructure patterns and scripting that makes deployments easier across multiple clusters. Bedrock is like our culmination of experience of how to run workloads in Kubernetes from working with several teams internally and externally. So this is a simple Bedrock scenario. Our friend Danny wants to download the Bedrock CLI and launch the dashboard. So he can download the CLI and run the setup command, and he can get the GitOps pipelines up and running by answering a few simple questions and using some personal access token for their ASDO. Danny can pull up Spectate by running the dashboard command, which is a simple command that will launch Spectate, as you just seen. So we find that this demystifies GitOps for a lot of people by giving you a rocket to go from point A to point B. So a typical Bedrock process goes as follows. A developer in the team merges a code change into the code repository, like we just did. This kicks off the CI build, which creates starts building the Docker image for a container registry. In this example, Azure Container Registry. And this change kicks off the second part of the Bedrock process, in which metadata is updated, such as Docker image tag, or any other config set up by the team or required by the Helm charts. So this is the change that basically configures your Helm charts. We have a concept of something called a high-level definition repository and a tool called Fabricate. So high-level definition is basically a high-level abstraction of YAML that basically gets produced into the Kubernetes YAML by using a tool called Fabricate. We will get to that in a few moments as well. And this is a great way to deal with multi-cluster and multi-region setups. After this PR gets merged, so the PR that we have just looked at, once that gets merged, the final step in the Bedrock process is triggered, which uses Fabricate to generate our high-level definition into the manifest that will be deployed to the cluster. And Flux is running on our cluster, along with being able to pull the Docker images. It can sync with the manifest repository and apply these changes into the cluster. And lastly, Spectate is capturing all of this data from this process. It's able to capture this metadata because of there's a few scripts that are embedded inside of these pipelines. And when you set up your pipelines using Bedrock, it kind of embeds all of this and scaffolds everything for you. So when you launch Spectate, all the data is already there. So we built Bedrock to create tooling and infrastructure with Terraform, GitOps pipelines, and observability. With our customers, we found that a tool that can automate setup and creation of pipelines, scaffolding of the high-level definition, and a quick way to get the dashboard up and running improve the GitOps onboarding experience. With Bedrock and Fabricate, it's easier to set up a high-level abstract YAML that describes the config in the cluster, and just two simple commands, fab install and fab generate, along with Bedrock setup. This really just makes it easier for someone onboarding into GitOps. So Bedrock has been used in a few projects, and these are some of them. We used this in the project that enabled COVID-19 exposure notifications across the United States in the continuous integration and deployment of the national key server, which allows for the anonymous identifiers known as temporary exposure keys to be exchanged and users notified if they have been exposed. We also applied this in our most recent Bedrock project to deploy Gen3, which is a data platform to build data commons used by researchers and bioinformaticians. So here's the fun part. Let's talk about how Flux 2 is able to improve Spectate even more. So for some of you, Flux 2 might just be a recap, but Flux 2 is basically the second part to Flux and comes with a lot of different features, such as a notification controller that can notify a webhook for alerts in the source, customize, or the Helm controller. It also comes with support for multi-tenancy and syncing with multiple Git repositories, and the customized controller for further customizations as well. These notifications can be used in tools such as Spectate to improve them even further. So let's see how. GitOps Connector is a tool built by a team here at Microsoft, which sits between the notification controller and CI/CD tools. And it sends enriched notifications as JSON objects to all of these tools to allow for even better observability. It can notify N subscribers with this data as well. So this really helps close the observability gap between Flux and the orchestrators. I'm going to navigate back to Spectate so we can see where our pipeline is at. And it looks like the PR has been opened. So at this stage, someone looking at Spectate would like to see what change has been made and what am I trying to deploy. So you can click and see the change that we've made into the code repository, and this one looks like, we are just changing the title. So that looks good. The pull request is a change being made into the config repository, which is a high-level definition. And in this one, all we're trying to change is the new Docker image. So as you can see, it's a very simple change, just changing the name of the Docker image. I can mark that as complete. And once that's merged, that will kick off the final step in our GitOps process. So I can wait for that to complete, or we can come back to it in a couple of minutes.
While we are looking at that, I have one question. Is there a hard dependency on the Azure CLI for Bedrock, or is it temporary?
This does not have a dependency on Azure CLI. So if you download Bedrock, you can use it on GitHub repositories or GitLab as well.
Okay, thanks.
Yeah, basically, if you download the Bedrock CLI, you can create a lot of these pipelines. And if I click on one of these, for example, I can click on this image creation pipeline here. And so this the scaffolding comes with all the necessary scripts to send data to Spectate. So all of this will already be done for you. The only thing that the developers need to configure is, the custom code that they need to build their own Docker image, and that can be, easily customized. So we're taking advantage of the multi-stage pipelines here in Azure, but we also have a few working examples with GitHub Actions and GitLab pipelines as well.
So it kind of provides a wizard for integrating with other sources where we're getting all the observability data. Right?
Yes.
Okay.
And all of this is pushing to a storage table. And the storage table is agnostic, can be any kind of a storage table. And that's what's basically powering all of this data behind Spectate. So it can, anyone can essentially, take this data and write up another UI for it, because we want to make this, easily customizable as well. You can go and change the columns if you need to. So Spectate is open source as well. Okay, so it looks like the ready to deploy column has been filled out, and we see something show up here. I'm going to get to that in a few moments, but it looks like our change was applied into the cluster. And if I go here and refresh, I can see that the title now reflects Hello Cloud Native, and we can see that this change was just applied. So for someone looking at this at Spectate, you can come here and see, okay, some change just made it into the cluster, who made the change, what the change was, and we can also see the status on the cluster. So that's the next part that I'm going to dive into. And this is what's being powered by Flux 2, essentially. I'm going to navigate back to the PowerPoint. So the cluster status that we are seeing is basically powered by the GitOps Connector, which is like an adapter that sits between all the CI/CD orchestrators and the notification controller. And as we mentioned, it notifies any number of subscribers. So Spectate was a subscriber in this case, and the GitOps Connector receives the raw notifications from Flux and sends them over to Spectate, and also other tools. Let's see an example of that. So here's an example of how the GitOps Connector has added observability to Azure DevOps and GitHub Actions. So the notifications it receives from Flux, it processes and sends it over to the APIs in GitHub Actions and Azure DevOps. And as a result of that, you have this UI on the manifest commits, so that users can go navigate into the manifest commits and see the status of those commits on the cluster itself. And here's
you may cover this later, but can you also give a comparison on when you have Argo CD UI, how is it going to help? Just a brief differences or the additional benefits that you get with Spectate on top of Argo CD UI.
Yeah, I think Argo CD has built a very similar GitOps experience. I don't have it pulled up right now. Let me navigate back to Spectate, but I think the idea that Argo CD, and I think even Flux is building the new Weave Cloud with Flux is coming up with observability tools as well. The idea I think is the same, and I haven't currently got the Argo CD one up and running, but Argo CD is probably able to give you a lot of notifications status updates from what the status is in the cluster directly. So it would look something similar to this. The experience, the UI could be different, but I think the idea is the same. I don't really have the UI up and running though. So.
Okay, nice.
Yeah, so I think that pretty much concludes my my live demo. And just wanted to call out that we are still in the process of enriching these notifications. And still the Flux 2 part you're seeing is still in progress. We are applying some of these in the Gen 3 project as well. Yeah, so that's the end. Just to summarize what we talked about GitOps, an ideal solution, and we talked about how we are addressing some of these in Spectate, and how Flux 2 is able to improve this even more. So at this stage, happy to take any questions again.
Awesome.
I think what I understood from the spectator side here, another spectator here, having observability inside the GitOps environment is a crucial one. I think it's a natural next steps in the evolution, right? Once we go from GitOps kind of a CLI tool, and then you need some kind of visual to see what is going on. Otherwise, personally, I felt like, okay, where exactly is my deployment? Is it done? Is it not done? Or exactly. What is the version that is available? So definitely, I think it's something that we need to see to be able to decide in that sense. Yeah, overall, that's a great tool, I think, for something useful for the operations teams.
Yep. I think myself, I'm new to Kubernetes. This is my first, working in this team when I first came in. This was one of my first projects, and it was very hard for me to understand what's going on, and that's why our customers were confused. And I think from there we decided that we should probably invest some time in building something like this.
Cool.
Can you share with us some additional customers that you're working with? Is any of that public? Just kind of curious, what types of what's kind of your ideal customer profile, and where are you hearing kind of the most interest for this?
So I know some of the customers we had were, I don't think the names have been released, but two of them that have been released I've shared on the slides earlier. Mm-hmm. I think, we are open to all kinds of customers on this, like, the ones that come with a lot of microservices and the ones that have some kind of a custom need, because that really helps us shape the product even more. So I think from here, what we're looking to do is there's a product called Azure Arc for Kubernetes, which is building, which is actually built around Bedrock, but it's coming out of the box with Azure. So we're really just, partnering with the Azure Arc team and a lot of their customers, and, just building this making this a built-in feature within Azure Kubernetes service. So that's where we're looking into next.
Is there a scope for adding more functionality in the CI pipeline? So I think the basics are covered in the sense you have a pull request, you approve it, but mm-hmm. Is there any additional logic that you can add? Maybe introduce scanning or anything that is related to business in the pipelines?
Yes, absolutely. So the pipelines are completely owned by the user and not by Bedrock. So the Bedrock can scaffold them for you, but what you can choose to do is not go through the scaffolding if you already have, a project that's already has its pipelines built out. So you can actually just take the Bedrock scripts that you need for sending the data to the storage, and then all of this is customizable. So even in this example, we have custom written these pipelines, and all of this is customizable. So what goes on inside of this is completely owned by the user.
Okay, and is it? Can you see this feedback on the Bedrock UI? Because I don't want to switch to multiple UIs to get a hold of what is going on. So mm-hmm. is the data that you see on the UI, is it customizable at the moment?
You mean this? Is this customizable here?
In the sense, like if I have one more step before approve pull request, there is one step.
Yes. So I think for that, what we would recommend is you fork spectate and you can add a column easily. So it's as simple as, you would be modifying the commands that send the data to the spectate storage and adding another field. And you can utilize that field to create another column. So spectate is open source and you can actually, modify, add columns and so on. Right now, we haven't added a feature, but this is something that's in the works. We've been thinking about how we can, make the columns customizable, because a lot of users, maybe someone doesn't want to have, 3 steps if they're a simple project, or maybe they want to have more. So that's definitely, something that we have on our list, but currently spectate doesn't support that in the UI itself. I think that needs to kind of, I'm hoping that we can get to that and make a feature for that as well.
Okay, that's it. And one last question around the partial releases. As in, can you do like canary releases? How do we visualize those canary releases? I think that is also one of the pieces where
Yes.
there's some request for sure when in case of microservices, like how do I do a partial release, right?
Yeah, so I think I can dive into a bit more detail with the deployment rings. So what you're seeing here is, a canary testing would be similar to a deployment ring. You can have another ring here, and let's say you have a feature, a very crucial security bug fix feature, and you can create a ring for that. How this works in Bedrock and Spectate is you create a new branch and you create it with a specific naming convention. So for example, you create the branch, you call it deploy / something, and that deploy / is like the keyword that makes it a branch that makes it to the cluster. So in this example, you can see we have three different rings. So you can see we have the backend dev, backend master, and frontend dev, frontend master, and so on. So we have 3 different rings, and those rings are basically being created for all of the different microservices. And that's what really defines where the users go to. So the production users are being directed to the front-end master website. And if I show the services here, you actually have a different external IP for your front-end master and the front-end dev. So the developers are going to this IP for testing, but the users are going to this. So I think the same idea goes for canary testing. You can create, more rings, and you can direct your users for each of those rings into those respective external IPs as well. Does that clarify?
Yeah, yep. Thanks, Samir.
Yeah, any other questions, comments?
All I have. Thank you very much.
Looks like we have some shy folks tonight. Anybody? We'll give you about 20 seconds to think about it. Going once, going twice. Okay, Samia, I want to thank you very much. That was an excellent presentation and demo. I really appreciate you putting that together. All of us like to thank you, and we definitely want to have you back in the future and hope you can continue to support our community. And yeah, that's awesome. Thank you so much. So I want to
are you going to be at the KubeCon?
I'm definitely going to try and make it if I can. Yeah, for sure.
Yeah, Josh and I are going to be there. We'll see you soon.
Oh yeah, see you at KubeCon then.
Yeah, everybody, we're hoping to have a party. We're trying to figure out how to do this. So anybody who's on the call, if you're going to KubeCon, reach out to us so we can make sure we got you on the VIP list. But for those of you who have not joined our community, I invite you. We're a meetup community, cloud native at scale, based in San Francisco. A lot of you do come from Eventbrite. I'd say about half usually come from Eventbrite. So if you coming from Eventbrite, you might not be a part of this. So I encourage you to join and would love to have you. And if you'd love to speak at one of our events, reach out to me. So this is our next event next week. So we're trying to do these events once. We're trying to get up to once a week. It's a little tough to do that, But yeah, so observability, showcaser, Jaeger, OpenSearch, and OpenTelemetry. We have some excellent speakers here. Joe Elliott is one of the core maintainers of Jaeger. Riley Yang is one of the core maintainers of OpenTelemetry. And Jonah is the CTO and head of product strategy at LogZ. And they are one of the contributors to OpenSearch, which is the forked off version of Elasticsearch. So, okay, guys, so without further ado, oh, and just to let you know, so that's going to be Tuesday, but it's a different time. That's going to be at 10 a.m. Pacific Standard Time. Okay, so 10 a.m. Pacific Standard Time. All right, everyone. Thank you. Thank you, Samia. Thank you, Shakri.
Thank you so much.
All right.
Thanks, everyone, for attending.
Thank you.
Thank you.
Bye.